All right, so you're welcome to today's session on our weekly session tagged Discovery for People Managers. So we've gone extensively far into the scheduled curriculum, and we've been dealing with SQL in the last couple of weeks. So we'll progress from there today and see what more clarifications we can do and how much confidence we can add or gain regarding taking on some SQL statements. So, by way of reminder or by way of refreshing our mind, so SQL is just a statement, and of course, it's a programming language that we use to query a relational database. And a relational database has gained prominence for a long time after the deficiency found or discovered with flat file database. And for relational database, from the word relational, it means the error discovered or the incapacitation discovered with flat file is now being taken care of by relational database. So instead of having all the different attributes, in this case, the number of columns you want to show on your data sets, instead of trying to find a way of putting them on the same data set, thereby complicating and making the entire data set complex in the long run, which is eventually not going to be useful for any analysis. It rather yield more confusion than clarity. So the rationale or the solution was that keep every data table as simple as possible. Let them just go for the function they are performing, and they can be linked together to speak to an umbrella table for any particular data set. So that will enable free flow of querying, and you can get as many extract of information as possible without losing any information and without having any complexity, as it were, in the long run. And that is what makes relational database superior to flat file database, and it's been in existence for quite a long time and up till now. So even the advent of the new technology that we are currently having, that's also brought up what we call NoSQL, which is no structural query language. It still finds a way of defaulting back to SQL and using SQL. So unless we get to the varied types of data sets that are not actually conforming to the data type or the structure or schema that is expected of a typical relational database. So, and at that, all of those um, very uh, unusual data type in terms of audio, in terms of images. There's no way an SQL database or relational database can store all of those type of data, which are actually data right now in this age and time, because data now flows in form of either audio or video and equally in different file types, which are not compatible with relational data base, but they can be converted later on to what can be fit or imputed into relational database after a couple of processes has been brought to bear on them. But that does not still reduce the relevance of relational database. So any database administrator, either then or now, cannot downplay the critical importance of relational database, and by extension the use of a programming language that helps to extract or query information from such database, in this case the structured query language. So that is what even makes structured query language itself very, very critical, and there are many types of it as discussed before. The one we are currently using for our practical class is MySQL. We equally have Oracle database that SQL can equally be used on, and you can imagine how extensive Oracle itself has been in use in terms of database in general. So we are in for an exciting time, and this particular skill, just like Excel too, which we dealt with for quite a long time, you cannot do without the use of that particular application in every workplace all over the world. And people who are smart in using it can quickly get their tasks and work or projects processed, and they could extract as much information as possible very quickly that could help them or aid their decision making or the kind of inputs they would be contributing in the course of any discussion or meeting or gathering or any situation whatsoever. So we can therefore move ahead from where we left off. So we discussed this uh, common SQL commands in the last session, and why this is important for everybody, not just people who are into full career or full role as data analyst and all that. We've established the fact that everybody needs to have a form of familiarization with data, and you can play around with some basic things. So before we begin to move into uh, other tools, in this case, other programming languages that could be slightly a bit more than SQL, maybe I would say slightly a bit, maybe slight technical, but with explanation and understanding, I have discovered that none of those languages are too technical as it were. It's just about understanding what they stand for. They are just language, and every human being has got a language he or she is speaking. So, as long as you can speak a language, then that means that there is actually no programming language you cannot learn because you've already shown the capability to speak a language in the first place. So computer language too can be learned and put into use, but the process has to be gradual, and that is why this curriculum has been so systematic in its structure, such that we are taking as many people as possible from a point of being a novice down to gaining some beginner understanding and graduating in that understanding. And our ultimate end is to move everybody into a position of expert. So two extreme positions. One, the position of being a novice, not having an idea of what this is about, and even being scared in the first place of when they mention computers, some technical things about computers and programming language for that matter, almighty programming language, people want to pick race and just leave it for some quote and unquote highly endowed people who are cerebrally endowed to take care of it. Whereas that is not the case. Everybody can have an understanding of it. It's just to ask as many questions as possible and seek clarification. So, having taken our time to deal very well with Excel, a measure of confidence has been built. And I could recall a couple of comments that came up in some of the sessions we had in time past. People began to mention the fact that they are gaining confidence in interacting and familiarizing with data now, which they wouldn't have been able to do before because there was this gap in between them and anything that is called numbers or data. So having done that for Excel and now going into SQL, so SQL is still very more close to human language or what we call natural language, as it were, because we use direct natural words that we use on day-to-day communication, even as a programming language. So which makes it quite easy to understand that okay, even the programming language as it were, they were just notation and symbols, and they were configured into an application that this is what they should stand for, and that is what that application understands. So when you speak that language, or when you use that notation or symbol the way that application has been trained or designed to understand it, it will give you a response, because you are speaking the language of that application and you are now able to communicate. So it can run whatever task for you with the speed of light, even faster than the speed of light, because you can now speak the language that application understands. But it takes time to learn language. Even human natural language requires some sizable length of time to understand. But as soon as the understanding is in place, then there is nothing else one cannot do with that language when that understanding threshold is already established. So, and that's exactly the pattern and the method we are following. So, on that note, we continue with this. We've spoken about this, the SQL common language and common commands and all that. And for avoidance of doubt, the most commonly used SQL command, it could be asked anytime, any day. Like I was discussing with some people, and that question normally comes up. It can just come up from any interaction. So what is the most commonly used SQL language? It is nothing else but the command called select. It is called select. It is the most commonly used because we use it for a whole lot of things and all that. So regarding SQL language, there are divisions or categories in which it is broken into. I will just speak in passing on them while we go into some practical demonstration. Then maybe in subsequent classes there will still be one or two items of the agenda that will enable us to discuss again on the different category of the SQL language. For the very first one, there is a category of SQL language called the DML, and the DML is simply the data manipulation language. So it is the set of commands or SQL statement that we use to manipulate. From the word manipulation, it means you attempt to change some things about already arranged set of data. So the data is already created. I mean, the table is already created in a database, and you're trying to make some manipulation, probably trying to update some of the entries in some of the rows on that particular data, or just doing a few things around it. So there are a set of commands that we use to do that. And there are also set of commands that we use for some other functions entirely. So for instance, for the data manipulation, when I want to manipulate some data now, I already have a data set in a table in a database. So I can use the word update. Update is one of the command used. Select is equally one of the command used. Where is equally one of the command used. So you just want to make some changes on the existing data and just make it as current or as reflective as possible of the current situation of the particular person owning that particular data. And similarly, there are also other categories of SQL um, um, codes or commands that are called data definition language. So these are set of commands or SQL statements that we use to create in the first place. We use it to create and establish a name or definition for a particular data set. An example of that is the word create itself. So when you are creating, you are trying to define something that has previously not been defined. So you are defining it for the database to see and record, such that when you attempt to retrieve that thing and you mention that same name or label, the system understands what you are talking about and will go straight into archive and bring it out for you. But if there is no pre-definition of some items and they are not existing in the database and you are writing a query to bring them out, is the system will be at a loss, won't be able to understand what exactly is going on. So there are a set of commands we use to do that. You have to create and establish something in place. So we use the word create is one of it, and another one is insert. Yes, you insert to populate a table newly created such that the table now has some data right inside of it and a few other things like that. So yeah, these are the set of commands for data manipulation. Then we can just go straight into a few demonstration on the MySQL server. So please confirm the screen is clear enough for you to see. So usually when you land on your relational database system, and in this case we are using MySQL to run this SQL language, and this is the server we are currently using. So you want to know what is the database you are currently working on, so that you'll be sure that okay, whatever action you want to be performing, either you want to create a table or you want to delete a table or you want to do anything, you just want to be sure that, okay, it is the database you have in mind that you're actually working on. Because if you, for instance, come up to bring up a table right here and you are not in the right database, the system will tell you the table does not exist right in that location. So you must always be sure that you are working in the right database that you want to work. So the best way to start, or a good way, you can just say, okay, let me even know what database are available so I can be sure that I have a few things that I need to know. So show database like we did the other time. So you want it to show the existing or available database so far. Yeah, here is it. It's showing me all the available database right here. I can see a database named information underscore schema. One is my SQL performance underscore schema, retail underscore skull, and all that. Those are the available databases. Then, okay, which of them do I want to use? I want to use, I'm sure I have a number of tables for our practical demonstration in this one called school underscore demo. So I can say use. I can say use, yep, school underscore demo. Don't forget, you apply your semicolon, then you highlight what instruction you want it to implement to execute, then control enter runs that code. By the time you look down, you see that the code has been run. It runs within 0.000 seconds, and it was successful, showing green on this side. So it means that I am now currently in this database called school underscore demo. So under school underscore demo as a database, I can equally tell it to show me the tables that are there. Let me be sure the table I want to play around with is actually there. So say show tables. Yes, run that, then it will give me the tables available in that database. So here you can see the output. The output is showing to me that okay, tables in school underscore demo. Don't forget, school underscore demo is a database. Then the tables available in it are listed here. One is named shapes. There's a table called shapes, and another one is named students. There's a table called students. So you may be wondering, what does the table look like? Okay, you can always check. Let's check the two of them. So I want to know, what does the table called shapes looks like. I can just say select, yep, select everything. And don't forget, everything, the language for communicating the word everything to SQL, that language is star. It doesn't understand everything as everything. And that's exactly what I was talking about earlier, that all of those different communication or words are changed stylishly into some code and symbol, and they are now used or defined for the programming language to be using to mean that particular word. So when you speak the right notation that the language understands, it will respond. So I've already said now select star, and that star means all or everything. And everything in this sense means all the columns. So it means all the column because tables consist of rows and columns. So I'm now saying select all the columns in where now? All the columns from where? From, I will now name the table. Now, let me name the table as shapes. The very first one we have there. Then you put your semicolon, select everything for it to run, then control enter, it will bring it out. So this is the table called shapes. It has column for ID, column for shape itself, column for color, column for dot, column for X log, which is more like X axis, then column for Y log, which is Y axis, and column for scale, because this is describing some shape and some of them are in 3 dimensions. So it's getting some coordinate, maybe the X coordinate and the Y coordinate, and even one in between, depending on whether it is a 2-dimensional shape or a 3-dimensional shape. So you can see we've gotten shapes, and you can play around shapes for as many things as possible. I can say, okay, now I have selected all the columns in shape. I can choose not to select all. So what do? I go back to change that notation that means all, which is star in this case. I can remove star. Then I have to specify to the server, okay, which column do I now want it to show? Since I don't want it to show all the column, no problem. I go ahead to mention the columns. Okay, I want you to show me column for ID, comma. I want you to show me column for, I can make it as serial as possible. I want you to show me column for color, comma, and I want you to show me column for maybe just like that, dots. So yeah, so I have said select column called ID, select column called color, select column called dots from the table called shapes. Then I go ahead to execute that command. It will go and give it to me straight, as you can see. So you can see it has gone ahead to withdraw the entire table, knowing now that that is not what I want. I don't want the entire table. Just give me a selected columns in the table. And that is the beauty of relational database and the use of SQL to query it. You can streamline what you want to see. You can expand what you want to see. You can reduce the length. You can just do all sorts of things. You can pick from different tables that are consisted in the schema of the particular database you are working on and pull out a few things out of them, and to display it, because the moment you are able to use the right communication word, in this case, the codes or the commands or the statements that SQL understand, it will go and pick all of those things easily and display for you. So I did that one using them serially. So I can equally say, okay, let me reduce all of this back to all. So I can figure out, I want to jump some columns just to see that, okay, you don't necessarily need to request them serially like that. I can jump some columns. So for instance, now I have all of them here. Okay, I want you to give me ID, good. Then I want you to give me um shapes. Okay, that's fine. I also want you to give me, don't give me color. I want to jump color just to show to you that you can jump from one column to another. You can pick the first and the third and the seventh and the eighth, and it will go ahead and bring it out for you. So give me the ID, give me the shape. Um, yes, give me dots. Don't give me color. I want to jump color. Then don't give me X axis. Don't give me Y axis. Go ahead and give me scale. Yeah, I have that. So I go ahead to select that because that is the command I want it to execute. So I highlight it as usual, ensuring I already put semicolon at the end of the statement. Then I run it. Either I run it using any of the tools here, or the easiest one for me, since my hands is on my keyboard, I can just do Control Enter and it runs it and fetches out that particular information I have requested. So I requested for ID, I requested for shape, I requested for dot, and I requested for scale. And that's exactly what that brought out for me. So that is for um, the table called shapes. Then I can equally go ahead and add more rows to shapes. And I can equally go ahead and do a few things around it that way. But as the time is already running, let's see what is in the second one. What is that one now? It said select all as usual from go ahead and select from the table called students. Then I have this one. I highlighted all, run the code. So here is a table called students, and this is the field we have in there. We have the ID column, we have the name column, we have age column, and we also have what is it called? We have the cost column. So I can choose to move around things here and just said, okay, I want some things to be changed. I just want to make some adjustments. Maybe uh, the student offering cybersecurity, for instance, has changed his mind. That was the choice upon admission or at the point of admission. But maybe right as time went by into the course, he or she felt he could not cope with cybersecurity again and probably wanted to change course. And if that change request is successful after following the right process for doing that, then the database record needs to also change to reflect what exactly is the new thing. So to do that, you just have to go into the database and issue a few commands. In this case, don't forget what I mentioned earlier as to data manipulation language, which is the DML. So they are the one you can use to manipulate. You change, you add, you bring in, you bring out, and all that. So I can just quickly say, okay, I want to change that particular request from that student, and the student in this case is Sarah, ID number 4, age 23, offering cybersecurity, now intending to make a change to that course. No problem. Since you want to make a change to it, no problem. We can do that for you. The command is just to update. So I'll just go ahead and update very fast this way. I'm telling SQL to go into the table called student, update it. Then what I want to change actually is the column, not age. The column is called course. So I will specify the column this way. So I want to set the course from cybersecurity. Let me say I want to set it to what program now or what course now. Let's say I want to set it to accounting. Yes. So I'll just put accounting this way. Then I'm now instructing the SQL program that, okay, where you are going to make these changes in the table, I have specified the table. I have told the application to change the cost to accounting, but I also need to specify which of the rows will I go and change cost to accounting. I also need to specify that. And the most or the safest thing to use to make that particular specification is always the ID, because in a table, ID are not duplicated. No two rows have the same ID. So if I say I'm using where the name is John, go and change the cost to accounting. It's possible in the data set that there are more than one student bearing John. So the system will be confused. So it may just go into all the name, all the places where a name called John is appearing and change their costs to accounting, regardless of what course they're having. So even if there are 200 Johns, then that's what the application will do, because you said you should change it to accounting where a name is John. So using a name is not the best because many people can have same name, but it is impossible for more than one entry to have the same ID. That ID is what we call the primary key. And the primary key is not always more. I mean, you cannot have two things having same primary key. So that's why we're using the primary key here. So here, what is the primary key for Sarah is number 4. The ID is 4. I'll just put 4 here to specify that particular instruction. That is done. I will just highlight this and execute this code. Okay, unknown column, accounting. So let's bring it out again. Select all from students. Yep. Okay. Let me attempt age first. Age, change age of same Sarah. Change age from 23. Change it to 20, for instance. What is the ID? The ID is 1. Yes. So I can delete this, go back here, select this, run. Okay, that went through. It has updated that. Then for me to know if that age has been changed from 23 to 20 for that particular person. So I will just go back and select all from that table called students. Yep. So run the code. Yeah. Instead of N, I press M. So it doesn't understand students. So that's why it's bringing up that query. Corrected that one to the correct spelling of students. Run the code. Yep, the code went. And it brings out this. So you can see, formerly, this ID number 1 was 23 earlier. This instruction has changed it to 20. So in the same way, you should have been able to change that course just like the way we change the name. Maybe there is something wrong between integers and string, but we'll see as we progress. So that is for table students. But in the same way, we can equally create new table. So, and we can attempt to do that now and just say, okay, we have added a table for students. Can we also, let's create a table. Create table. So what do we want to name the table now? Okay, because you have add students, and I say we are in a database called school underscore demo. In a school, we have students. Okay, we should have teachers too. So let's create a table for teachers since we have had a table for students. So I can name this table teachers, right? Yes. So that's fine. I can name it teachers that way. Then I want to start mentioning what I want to be in the table. So for the table called teachers now, how do I intend or what do I intend to put in it? So I want it to have an ID, and in having an ID, uh, what would be the data type of the ID? The ID should be an integer. Yep. And do I also want to set it to primary key? So I'll put it there, integer primary key. Then what else do I want to do? Do I want to be regularly or manually updating the ID number as the data table is expanding, or I want the application to automatically increase the table by itself and generate an ID. This is where it is specified. So you have to specify right here such that the ID is auto-generating. So I can say, okay, I want the ID to be primary key, and of course it should be in number, and that should be integer. So those are the data type and instruction I'm already specifying now. And I also want it to be auto generating itself. So I will just say auto underscore, yes, that's brought it for me. That will be increment. Yes, so auto underscore increment. So I have specified what I need the ID to do. Then next, what other column do I want to be or to have in what other column do I want to have there? So I also want the teachers to have a name, right? Yes. So in having a name, then it would be what is data type of the name? It would be a variable character. So we use a varchar. Then I can specify the length of the varchar in any case. Let's just use the default 50 this way. Yep. So what else do I also want to have? Let's say I also want to know the years of experience of the teachers. Yep. I'll put experience this way. Then experience, what kind of data type is it? It's going to be in numbers, and just like ID, then I'll also give that one integer. So yes, it will be an integer. I can close that. Then I can move to the next one. What other thing do I want to be on the teachers table? Okay, I also want to know the designation of the teacher. So is the person a doctor or a professor or what have you? So I can say designation, and what type of data would that be? It will be in the same range with name. So I will use varchar, which is variable character. Then I put this, then also just use the 50 limits to hit. Yes, so I can now say I want to close the command this way. And I can check through. Yes, it appears there is no error to fix. I'm creating a table. I want you to name it teachers. I've specified the column. The column one column should be an ID column, set it to primary key. Another column should be for names, and the data type that will be there is this. Then I want the length or the character number to be 50 maximum, because some people can have a very long name. And that same thing goes for the designation. You can also have the same character limits. Then experience will be an integer, just like the ID number, which is also going to be an integer. So let's run this and see how our table is to be created. Yes, I can see that runs fine, and the table has already been created. This is the instruction here: create table, teachers, ideal integers. Everything is correctly affected, and it was done in 0.015 seconds. So how do I know if that table has been created? Very simple. So I'll just say, initially we said show tables, so you can ask it to show tables again. Initially, it gave us two tables, and that was shapes and students. Now we have created another table. We named it teachers. So let's ask it to show us the available tables again and see if it has included teachers in the number of tables we now have. Okay, show tables. Yeah, there you go. We now have shapes as it was there before. We also have student as it was there before. Those were the two initially in the database called school_demo. But now we just recently created a table called teachers. And here is it, teachers. There are now three. So this shows how easy to run this and come up with a result as simple as it is. Okay, we have now created a table. The table will only have headers. Don't forget the table does not yet have data inside it. So I can also say, let me see the table itself. I can say select, let's see if there's anything inside the table. Select all from um teachers. That's the name of the table, teachers. Put the semicolon, highlight the whole of the command, execute the command, then it will bring the table out. So because the table does not have any data in it already, the only thing is showing to us is that, okay, there is a table header column called ID, another one called name, another one called experience, another one called designation. So this is the table we have created, but we have not put what is it called? We have not put any data inside of it. So we can just quickly put a few data in it, and that can be a little bit fast because of my time. So to put data, we have to insert data. So the command is insert, which is did. So I'm saying insert into teachers. So it has a column called name, a column called experience, a column called designation. Then you'll be wondering what happens to the column called ID. It's not needed again when inserting data, because while creating the table, we've already specified the column called ID to be the primary key. And we have also set it to self increase, or we have set it to auto increment, meaning that it should be increasing and generating new ID for new rows being inserted into the table. So now that I want to insert data into the table, I don't need to say anything about ID, because automatically that instruction that we imputed while creating the table will be obeyed anytime you are inserting any data inside the table. So um, I can look away from that column called ID. It will self-generate by itself. So that is set on automatic generation. So the other columns is what I will pay attention to, which is now my name, experience, and designation. So you can just go ahead and change these names, tweak it around. I can say, okay, give me Babs. That name should be Babs. Then what is the years of experience of Babs? I can change it to 11. Then is Babs a doctor? I can say Babs is a minister this way. Then I can go ahead to do double insertion, not just one row. I can do as many rows as possible at a single time. So I just come here and duplicate it. Then this one should have its comma normally. Then I can change the name of this teacher. It's no longer Babs. Let's say the teacher is Jane. Then the years of experience is possibly, let's say, 17. And for somebody with a 17 years of experience in the teaching profession, should be like a professor. Okay. Yep, yep. Then I can duplicate it again and just do one more. Yeah, I do one more. I close this one this way. I can say this teacher, the name is Tom. This one is 14. And this one, this designation is a doctor. Just play around those stuffs that way. So there's no red line, underline anything anywhere. So it shows that the command is fine, the codes are okay. Then I can run this. Okay, insert, execute. Yes, that also went fine. As I can see, it ran in 0.000 seconds. That is 0 seconds running. That is too fast. So it has inserted those 3 rows. How do we know? Then we now go ahead and tell it to show us the table. Initially when we asked SQL to show us the table, it was just an empty table only having a header. But now that we have inserted some data, let's see how the data looks inside the table. Okay, what will I do? I just say select all from what's the name of our table now? The name is teachers. Put your semicolon. Highlight the entire code. Implement. Here is a table. This is the table we just created together with the data we have inserted inside the table. You put Babs, 11 years experience, designation is Mr. We put Jane, 17 years experience, designation is Professor. We put Tom, experience is 14 years, and the designation is Doctor. So that is how easy it is to come up with your own table and impute it. So by next session, our intention is to show us another way of getting a table inside your SQL database or SQL server. It's good to know this manual process and also be able to know how to manipulate it at any point in time. But there's a faster way we will demonstrate in next section, hopefully next week, where you can also import a whole set of data directly, and it has as many columns, I mean, as many rows as possible, maybe up to thousands of rows. So instead of having to impute like we have done, but this imputing skill is also needed because there will be times you just need to insert just a single record. A record is just a single line of observation. I mean, a single row to be added to a data set. You don't need to be uploading a file for that one. You can just use a simple Excel command to get that particular entry into the existing data, the existing table in a database. But if you have the table already in another format on a particular file, so we should be able to just import that entire file into SQL and display the table right here with few clicks. But before we do that, we will find out, okay, what format must that data set be? Will it be in an Excel sheet? Will it be in a typical flat file sheet that we saw earlier? Or will it be in a comma separated value format of data? We'll see that and just save some file in those different formats, then attempt to import them into SQL this way and also display them as it is. So that is how we can impute and also work around the table we have created. So what else can we do here? Um, you can choose to select just few and not just having the entire. So you can say select, just give me name and give me designation. Where will you get it from? From a table called teachers. I put my semicolon here. I like this, execute this. So you can see it's doing exactly what I wanted now based on that command. And it has given me just a brief view of that same table we had now. So what I'm just seeing is just the name and designation that was requested for, not the entire thing. And that's exactly how easy it is to move around different stops in Excel. So we've been able to play around the data manipulation language now and the other one for creating and defining data definition language. So we have used create. So I deliberately use create because you are trying to define the new table that was not in existence before, and we also went as far as specifying the data type, and that is the beauty of the definition. You are defining the name of the database, you are defining the name of the table, you are also specifying some attribute about the columns. The columns are equally defined, and now the attributes of the column are also specified. So what that means is that if anybody who is given permission to impute some data in that table attempts to impute data in a table without following those specification. For instance, we have said that the ID must be integer. Okay, let's say the system we auto generate its own ID by itself. So that may not be an issue, whether or not the person get it right. But there is another part of it that is also an integer, and that is the years of experience. So if somebody is not trying to impute data inside that table, and the years of experience, instead of being written in numbers, which is integer, the person now wrote the years of experience as a string in words. So programming language understand words or text as string. They call it string. So it's the data type that are written in letters are called strings in programming language. So you will see it as string. Meanwhile, what was originally defined into it while creating that table was that when imputing this data for experience, it must be an integer. That's why I use int. Int means integer. So if this person is now imputing and what is using for the experience, he now wrote the experience in words instead of writing it in figures, then the system will not accept it. And those are one of the we'll call it advantages of relational database. It helps you to keep your structure and control in place. If anybody attempts to play around it and does not follow or respect the initial specification that were given, it will never accept such instruction. It will block out that particular instruction and it won't add it to the table. But it also has a disadvantage. What it also means is that if you have a large data set in which you have that particular column for experience, some of the entries are written in numbers, which is integers now, and some of the entries are now probably mistakenly written in words. It will not accept that particular file upload or file export because there is issue on the part of some of the columns. And that is why prior to doing a few things, you want to do data cleaning, you want to do data preparation. Those are part of the things we look out for to ensure all columns are speaking the same language. I mean, all the entries in a particular column are speaking the same language, because if that does not happen, if a particular entry in a column is going south and some other entries are going north, during analysis, they will not unify to give you meaningful information of what is happening inside that data, because they will be talking about different things. This one goes this way, that one go that way. So the kind of feedback you'll be getting as an analyst will not be anything helpful. It will even lead to more confusion, as it were. So that is why it is quite important to first scan through your data set to see where there are possible issues that you want to fix before you upload into a higher level of application this way. So I think we can walk around this for today. Do I have any question while we prepare to go ahead or increase on that by next section to deal with how to import directly from other data sources without necessarily having to manually impute the data sets inside the table we just created. So those two skills are needful. There are situations that will call for you, that will require you to be able to impute directly, because what you want to impute are not much, just a few things. So a few line of code will help you to do that. And there are situations where you have a very large data set. You cannot be imputing one by one. So in the absence of no question, want to say thank you once again for joining today's section. The recording will be in the same location for us to use. See you next session next week, and bye for now.